Welcome to the TypeScript crash course, and let's begin. So, first question, what is TypeScript? If you watch this course, you already know that TypeScript is a programming language that is very similar to JavaScript, but with more typization and features that help you to write your code effectively and control quality. More typization. That is what I said before. What does this mean? In pure JavaScript, if we have code that depends on variable types, we will need to check the types of these variables again and again. But in TypeScript, we don't need to do things like this, because TypeScript has a nice advantage where we can set the types of every entity. About typization, we're gonna talk more in the next lesson. For now, let's continue our talk about this course. A few words about me. Oh, I forget to introduce myself. So, my name is Damien Kostelny, and I'm middle PHP developer that also works with many JS technologies like Vue or React. I'm an ATVDN courses supporter, and also I have my own articles on Medium, and you can find other my courses on Udemy. And if you so I think that's all that I need to tell you about myself. So let's continue our course. The main focus of this course. The main focus of this course is you to teach how to work with TypeScript, and we're gonna learn the main things that you need to know when you're gonna start building projects that use this programming language. What you gonna learn in this course? You're gonna learn everything about typization, classes, interfaces, and many other things in TypeScript, and many other fundamental topics that you need to know. You will know how to work with all these important things, and you will see how it's cool to use TypeScript in your projects. What do you need for this course? First, you need to have some junior experience in JavaScript and Node.js programming. The next thing is to install Node.js with the npm package manager. And the last thing that you will need is a code editor. I'm gonna use Visual Studio Code in this course as code editor, and you can use any other code editor that you want. Some advice about learning. And here I want to give you a few small pieces of advice for learning this course. Use additional materials that will be added to every lesson in this course. It will help you to better understand what you're learning and repeat what you studied. Make notes for every lesson. This also will be useful because if you forget something, you can check your notice. And the last piece of advice, make practice, and again practice with everything that will be in this course. So that's all that you need to know about this course. Let's begin learning the TypeScript programming language. So thanks for watching, and we're gonna meet in the next video. So welcome back, my friends. In this lesson we will install TypeScript using the npm package manager. So let's begin. Install TypeScript globally. Here is a straightforward command that we can use to install TypeScript globally in our system. npm install gflag TypeScript. Wait before TypeScript will be installed, and after that we can start learning this programming language. So open your terminal and just type this command. And if you use, for example, macOS or Unix or Linux, you need to write sudo command before this command. And after that you will type password of your system, and TypeScript will be installed globally. Code compilation. Here is one crucial command that you also need to know. This is really simple command that calls TypeScript CLI, and the name of this command you can see on the slide. This is TSC, and after that you're typing TypeScript files that you want to compile. So now I'm gonna open my first empty TypeScript project where we're gonna start building our first examples, and also we will check how this command works. So as you can see, I opened a new empty folder where I'm gonna set up my TypeScript examples, And first I open it my terminal, and here I need to type command npm init and EA flag. Okay, nice. And now we can start building our first example. So first let's create a new file that named app.ts. So as you can see, I created app.ts file, and .ts, this is an extension of TypeScript files. So files that have this extension is files that have TypeScript code. So now let's write next code. That's gonna be really simple. We're gonna just call alert function, and let's type here hello TypeScript. And now let's compile this file. So I type here tsc app.ts, and as you can see, here is compiled code of our app.ts. So this is compiled code of our TypeScript file, and as you can see, here is nothing special. There is no difference between these two files because we call here only one function that is built in JavaScript function, and we don't use it here. Some TypeScript features that we're gonna use in next lesson, and we're gonna talk more about how TypeScript compiles this code in next lesson, but you also will see difference between TypeScript code and compiled TypeScript code. For now, you now know how to compile TypeScript code, and now let's do one small example. So imagine that we have variable that is integer, and TypeScript have first features that you need to know. This is defining types of the variables. So you type here these two dots, and after that you can type of the variable, and as you can see, variable a now have number data type. We're gonna talk about TypeScript types in one of the lessons, but for now you need just to know about these features, that this is way how you can define type of the some variable, and you can use this. Now let's create a new variable that's gonna be named b, and this is gonna be string variable. This variable have data string, and let's type here, for example, string type. And next thing that I want to do, this is write next code a plus b, and let's try to compile this code. And if you open app.js, you can see there is one difference, and because we don't do here some, we don't use here some type of function or something like this, and this code is so simple, then we get also simple result. But you can also, let's try to do next thing, and you can see there is one error, and see what will be if I try to compile this code. You can see there is type number is not assignable to type string. So one of the great features of the TypeScript compilator, this is that you can see all errors, you can see all your warnings, you can use it will show you error immediately when you will try to compile your code. And this is really great to use TypeScript in your projects, because you have many more typization, you can control types, and you don't need, you have more control with data types, more control with function, and soon I'm gonna show you how it all works, but for now that's all what you need to know. So now I'm gonna just change this to number, and next let's create a new file that's gonna be named index.html. Let's also compile our app.ts, and now let's call here doc type. Let's also type here header TypeScript crash course. It's going to be title of our page, TypeScript crash course. Let's open body of our document, and let's include here our script app.js. Now let's open our browser, open this page, and let's check, let's check console. So as you can see, all works perfectly, and our app.js file is now included to our index.html. And that's one of the way how you can compile a TypeScript code. You just compile your TypeScript code, and after that you can include this to your your web page. And also some JavaScript frameworks like Vue.js or React can use also TypeScript for compilation, and that's also really good to use, because as I said, it gives to you opportunity to more control in your code. A few words about TS configuration. There is one crucial file that is named tsconfig.js, and you will need to use this file if you want configure process of the compilation or debugging. And in this file you can type which files you want to compile, which folders, and where you want to make output of compiled files, and many other things that make control of compilation process. So now let's go to the Visual Studio Code and let's create a file that's gonna be named tsconfig.json. As I said, we're gonna talk more about TS configuration in one of the lessons, but for now let me show you a small example of what you can do with a TS configuration. First, you need to create a tsconfig.json file, and now let's write some options. But before I'm gonna write something, I need to create this file. So tsconfig.json, and now let's write in options that we want to compile all the files that are in the src directory. So first we need to create a src directory, and let's type here, let's create a here new file that's gonna be named, for example, I don't know, maybe example.ts, and let's write here var b number 55. And next, let's back to the tsconfig.json, and now let's write that we want to compile all files that are in this folder. So I type here src, and that means that it will compile all files that are in this folder and compile all files that are in the folders that are in src folder. Now let's compile this. So let's type here only one command, tsc, and as you can see, this compiles also src folder, and this works perfectly. And also I can delete app.js, compile again, and as you can see now this compiles only files that are in src folder. So this was one small example that show you how you can, for example, configure which files you want to compile or folders that must be compiled. Summary. So what did we learn in this lesson? First, now we know how to install TypeScript, and you see how it's simple to use. We did learn how to compile code, and you also save a small example of defining types for the variables. And we save a small example of the tsconfig file. In the next lesson, we're gonna talk about types in TypeScript. We're gonna see which types we can use, how we can use them in conditions, and more. So thanks for watching, and we're gonna meet in the next video, and bye bye. Welcome back to the TypeScript course. In this lesson we're gonna learn how to use many data types that exist in TypeScript. So let's begin. Primitive types. So there is 5 primitive types that we can use in TypeScript, and you already know about this type because you already used these types in vanilla JavaScript. So this is string type, this is number, this is array, and boolean. And also don't forget that functions can also be as types, but we're gonna talk about this later. For now, let's do one small example with all these types. So let's open Visual Studio Code. Okay, so now I'm in Visual Studio Code. As you can see here is first example with number type. We can create here, for example, string, and it's going to be named ctr1 string, and I can type here, for example, this is string type, and let's create also some array. Yeah, so if I want to create the array value, gonna be like like this array. Yeah, and yeah, we're gonna also talk more about arrays, how we can find arrays that can contain only one type. For example, we can now create arrays that have only strings, and I need to open brackets here and type here type of array, and it's gonna be string. And here this array can only save some elements that have string type. For example, I can type here element 1, element 2, and if I type here 5, you can see the type number is not assignable to the type string. So we just created array that can only contain strings. And let's also create some boolean type, for example bol1. I type here boolean, and it's gonna be true or false. And here is also another type that we can use in TypeScript that is named any, and type any, and here you can type everything that you want. You can type here strings, you can type here boolean, Yeah, so this type is used to if you need to create some flexible variables that can contain any data type that you want. But now let's talk more and more about type, because I just showed you really primitive and quite simple example. Now let's talk about functions. First, let's look at the small example with an additional JavaScript function. So for example, it's going to be a function that is named add, and this function will have two variables. One is n, second variable is y, yeah, and it's gonna be return x plus y, and that's all. You can see that we have two variables, as I said, but there is one problem. If we will put no number type to the x or y variable, we will have an error, yeah. So for example, if I will type in TypeScript code 5 plus, for true, and if we're gonna try to compile this, if we're gonna define type of this, yeah, we don't have control of types of these variables. We can because we didn't want to have situation where we get result where we, for example, adding number value with string or boolean or other. So here we need to define types of these two variables. So I'm gonna type here number, and I'm gonna type here also number. And as you can see, here is error argument of type boolean is not assignable to parameter of type number. So as you can see, when we typing that we want to use only numbers in these two variables, Visual Studio Code will say that, hey, there is one error. You can't use other types than number in this function. So I'm gonna type here 10. This is example how we can define types for the variables that are in function. So for function variables, this is really cool. And there is also another solution if you want to check, for example, types of these variables. For example, you can use type of operator. This is in vanilla JavaScript, but we're going to talk about type of operator and how you can check types, and also we're going to talk what is union types later in the next lesson. So now you know how to define types of the function variables, but you can also define type of the return state. So you need to add here two dots and type of the return statements. So we're gonna return here number value, but if I, for example, type here string, you can see here is error because type number is not assignable to type string, because here it returns number value, but we can do here one interesting thing. We can type here result, yeah, and it's gonna be make operation with x and y, and y variable. You can type here result to string. And now we fixed this error. So this is way how we can define, return statement type. Yeah. And this is a much better way of defining the types of variables instead of creating conditions that will check the data types. What I mean about conditions, for example, we typing here, for example, type of x is is string or number. Yeah, we can use use also this way that I just showed you. But now let's talk about which types is required. So for now, by default, these two variables is required, but we can also add variables that it's gonna not be required. And when you typing variables that is optional, you need to type here this symbol, and you can see there is no errors because this is optional variable. But what if we want to use this variable? We can type here, for example, if z, yeah, we create a if there is a z variable. We can type here x, yeah, we can stop. Let's copy this code and type here x, y plus z. So that's how we can use optional variables in functions. And yes, we can also define the default values of the variables. If you want this, it's gonna be like this. So type here the default value of the x, it's gonna be 0, and also default variable value of the y variable, it's gonna be also 0, and z also will have 0 value. But you can see here is error. Parameter cannot have question mark and initializer. That means that the optional variables can have some default values. So you just learned how it's simple to work with the functions in TypeScript. Now let's also look at the small example where we defined a variable that has a type of array with strings. I already showed you how this works. Yeah, because let's again look at this example. So imagine that we have functions that save some data to JSON, save to JSON format, but it's gonna be named save2json names. And we will have variables that is gonna be named names, and it's gonna be have array with strings values. So this is also one of the ways how we can define arrays that can contain only strings or other variables values, I mean types. And for example, we can type here number, or we can type here boolean, yeah. And it's gonna be only contain variables, elements that have type that you defined for this array variable. Now we can type here, for example, return JSON stringify names. So that's the way how you can also create arrays with special types. Perfect. Now let's move on to the objects in TypeScript. Objects. Maybe you know that if you work in JavaScript, if you want to pass some big record with data, we can use object. Let's look at the next example. So first let's create a new function that's gonna be named getFullName, and here will be user variable, and it's gonna return username, and it's gonna also return user last name, yeah, user last name. And here, as you can suggest, we're gonna use here user variable that will have object type, and it's gonna save some parameters that have values for the name and user last. But if we will use TypeScript, we can define parameters in the object that will provide it to the function variable. So what this means? This means that I can just type that we will need to pass here objects that have only string parameter and also last name parameter. So as you can see, we can type in the arguments object, you know, when a function will work with some object, you can already provide this object instructions in variables. So that's how it works. But there is also a more elegant way to provide object type to the variable. For example, we can create an interface that will describe the object, and after that you use this interface as a type in the function variable. So I'm gonna create here new interface. And yes, about interfaces we're gonna talk in one of the lessons, but for now just look at this example. So I type here interface user full name, yeah, and it's gonna be have name string, yeah, and also variable last name string. You can see we define these two variables with string types, and we can say that we want to use here this interface, and this is gonna be also work perfect, but we will need to provide here objects that have this type of this interface, and yeah, this will be also work perfect. So about interfaces we're gonna talk in the next lesson. Let's back to the object types, and you just saw how you can use object types in the variables of the function. Now I want to show you one modifier that you can use. It's named read-only. What means read-only? For example, you have read-only, and that means that you add this modifier to interface variables or object variables. You can't modify now values of these two variables. For example, if I gonna try to type here username equals username plus, and for example let's type here maybe some smile, you can see cannot assign to name because it is a read-only property. So when we using this modifier, that means that we make these two variables immutable. So if you want to create variables that can change their values, you can use this modifier, yeah. And for now, that's everything that you need to know about object types. We're gonna back to this topic when we're gonna talk about interfaces. Union types. Imagine that we need to use only two types in the variable, and how we can do that? Here we can use a feature that is named union types. And here on slide you can see one small example, a function where I forget to put name of the function, but here there is one variable that can use two types, number or string type. Now let's try to do another example with union types, and you will know how this works. So for example, let's create a new variable that's gonna be named add, and let's create here x variables that can use string or number value, yeah. But you can also create another variable that's going to be named y, and can also use number or string type, yeah. So we can use now number, strings, data types, as I said, but what if we put here not defined types in the variables? let's try to do this. So for example, what if I will try to call here, for example, if I will put here, for example, 2, and here I'm gonna put true. You can see that there is also error because argument of type boolean is not assignable to parameter of type string or number. So our variables can now use or string or number types, as I said. And union types can also use it in return statements. You know, for example, imagine that I want to return here string. Yeah, I can return here string, all null, and I can type here return, for example, x. But you can also see that when we try to return here, we need to check type of the x variable. For example, if type of is string, we're gonna return here return x to string. Yeah, but there is, yeah, it's not assignable to, yeah, maybe we can just type this type here to string, and I fix it. Okay, great. So in this course you will see many examples of where we're gonna use union types, but for now that's all what you need to know, that if you use union types, that means that you can now use 2 different types in one variable. And good, now let's move on to the examples of these features that will be learned in this lesson. So, and the first example that we're gonna check is creating a function that will make the sum of the numbers in the array with the number data type. So I'm gonna create a new function that's gonna be named addList, and it's gonna have numbers variable that will have type of numeric array. And first, this else function will also return number value. Yeah, and first here will be variable that's gonna be named result, and it's gonna be this variable will have number type, and it's gonna now map. We're gonna call now in this numbers array map functions to get values of numbers that will be provided to this array. Yep. So I type here result plus num, and it's gonna get value of all added numbers that are in this array, and I can return result. So that's how it works. It was really small example, but let's try another thing. For example, I'd type here 1, 5, 8, 10. Yeah, and let's now call console log function, and let's call here addList function and type here list. And you can see there is no error. I can also call here TypeScript compilator, and if I open example.js, you can see there is not much difference. But that's how one of the examples how we can use union types. So I mean not union types. That's how you can use types and how you can also create arrays with our types. Okay, quite a simple example. And now let's do example with union types. Now we imagine that we need to create a simple function that will get user data and return this user data in the JSON format. So imagine that we have interface that is named user, and user can have name, user can have, for example, last name, and also can have, for example, surname. Yeah, and it's going to be optional, this parameter in this interface. Yeah, you can also define default values of the interfaces. You can type here, for example, no surname, and it's going to be default value of this variable. Yeah, and next let's also create a age variables. It's gonna be union type, and age gonna get age data in number type or string. And let's create a really simple function that's gonna be named user to JSON user. And you can see that we type it here user interface, and it's gonna return string, and we need to type here, for example, that JSON stringify user. So it's gonna be return JSON data of the user. Yeah, so that's how it works. So now let's finish this lesson. Summary. In this lesson, we learn a few things. First, how to define data types in the functions. Second, how to define data types for the return statement, how to use object types, and how to use union types in the variables and functions. In the next lesson, we're gonna talk about what is narrowing in the functions and how we can use this. So, thanks for watching, and we're gonna meet in the next video. Hi and welcome to the fourth lesson of the TypeScript course. In this lesson, we're gonna learn what is narrowing in functions and how we can use this feature in TypeScript code. So, let's begin. What is narrowing? So, what is narrowing? First, imagine that we have a function that will sum two variables or unite them if these variables have a string type. So now we're gonna go to our Visual Studio Code editor and we're gonna make one example. But here on slide, you can see one operator that we're gonna use soon. The name of this operator is typeof, and you maybe already know about this operator because this operator is used in vanilla JavaScript to check type of the variables, and we're gonna use this to check types of the variables in narrowing. Soon you're gonna see how it works. But now let's open Visual Studio Code. Okay, I'm here, so now let's clear our code that I wrote in the previous lesson. And now let's create a function that's gonna be named add. Yeah, add. I again creating this function, and imagine that we have two variables, x that can accept number or string data type, and also y function that can also accept number or string data type. And imagine that we want to return some of these two variables. And you can see there is one error because operator plus cannot be applied to the type string or number and string or number type. So that's situation where we need to use narrowing. There is one way how we can fix this, and here we're gonna use typeof operator, and it's one of the types of narrowing. So narrowing, it's like check types of the variables, check values, and many other things that you're gonna see now. So first let's check types of these two variables. So if type of x is equal to string and type of y is equal to string, then we're gonna do the next thing. We're gonna return this like a x to string and y dot to string. So we're gonna transform these two variables into string data types. And in else statement, we're gonna do next thing, or we're gonna, we can just write else if, also, but in else we're gonna just do one thing. We're gonna just type here x and y, but you can see there is an error, so I'm gonna create here new situation where x is equal to number type and type of y is equal also to number type, and you can see there is no errors and it's gonna be work because I want also to say that compiler of the Visual Studio Code sees that we are using here type of narrowing. This is situation where we're using type of operator for narrowing, and you can see that there is no errors for now. Yeah, and as you can see there is also error, but we can just clear this. Yeah, and we fix it. So we fix it. If we will compile this, everything will works. Yeah, all compiles, that's good. So that's one of the types of narrowing where you can check the types of variables. We just talk about union types narrowing, yeah, because we use it here, union types, and that's the name of this narrowing type is union types narrowing. Now let's check the next type of narrowing using the in operator. So using in operator. If you need, for example, to check which function exists in the TypeScript class, you can use an operator that is named in. So first, let's imagine that we have one class that is named frog, yeah, frog, and let's imagine that we have here one function that is named ribbit. You already know that frog making ribbit sounds, quack quack, and other, and we're gonna just type here, for example, console log ribbit. Okay, and now let's also create another class that will be named cat. And as you already know, cats make sound that sounds like a meow, and we're gonna type here meow meow. Yeah, meow meow, 3 dots, okay. And next we're gonna create a function that is named make sound, and here we also gonna use union type. Yeah, so first let's type here make sound, and here is be one variable that is named animal, and this variable will accept frog type class or cat. And if we have repeat function in animal variable, so we're gonna call repeat function. Then if there is no, therefore if there is no repeat function, we're gonna call meow function. Yeah, so meow. And as you can see, there is one error. Property meow doesn't exit on type frog or cat. So there is one solution. We can just type here else. Yeah. So if it puts this to else, all will be works perfectly. So we just use it in operator to check that we have repeat function in frog class objects that we provide to the animal variable. So that's how it works. That's the second type of narrowing, by using this operator that is named in. So you can use this, for example, if you want to check if you have some function in some class or object of the class, and you can also use this in async patterns. And now let's move on to the next topic that is named call signatures. Call signatures. Call signatures is a way to get properties from the function. So you can see here one example where I have type that is named addFunc. This type have one variable that is named x. This variable have number type, and next what we see, this is function that is named callFunc, and you can see there is inside this function one variable that is named callback, and this variable have type of the addFunc. Yeah, so we created here custom type. Yeah, and also we're gonna talk about custom types in one of the lessons, but for now you can see here is one example where we're creating a custom type that is named addFunc, and you can see that inside of this function we get property from this function. So call signatures, as I said, is way to get properties from the function. So now let's try to do this example, and we're gonna also this compile code and test it in browser. So let's do this. So okay, I'm here. Let's clear all code that we just wrote. Now let's try to write addition function. Let's write here type that is gonna be named addition function. Let's open it, and let's create here new variable that's gonna be named string. After that, we're creating new functions that maybe let's name this function call something, and let's create here variables that's gonna be named fn, and the type of this variable, it's gonna be addition function type that we just created. And after that, we type here we call here console log, and we're gonna type here comment is we call this variable, and you can see we can now get this property from this type, and we can type here fn comment. Now let's try to do one example with this. For example, let's imagine that that I want to create an addition of fn. It's gonna have type addition function, this variable, and let's create here new comment, and let's write here, for example, we're learning TypeScript. Yeah, okay, great, it's learning TypeScript. And now let's call function that is named call something that I just created, and let's put here this function at the end. And as you can see, there is no error. So now let's compile this code. Okay, it's compiled. Now let's go to the index.html, and now let's include this file that is in src folder. Great. And now let's open browser and check the result. And yeah, also you can see code is compiled. So now I'm gonna open my browser and check the result. Okay, so now in the browser, and as you can see, there is comment that is relearning TypeScript, and you can see that all works perfectly. So that was one small example of call signature. Now let's back to the Visual Studio Code, and now let's make another example where we're gonna use another feature that is named constructor signatures. So let's do one example with this feature. So let's go back to the example.ts file, and let's create a new class that's gonna be named addition class, and it's gonna be empty class. Okay, now let's create a new type that's gonna be named for example addition function, as we did this in previous example, and we're gonna create now here constructor signature. So To create a constructor signature, I need to create a type here first new operator, type this, like we're calling one function, yeah, and I need to type here addition class. So this gonna now create a new object of the addition class. And for example, let's create it here now, add function, for example, or for example, I don't know, create a addition, create a addition. It will be name of this function, okay. Addition, okay, great. And here we're gonna create a variable that is named add series, and the type of this variable is gonna be addition function. And let's open this function, and here we're gonna type new add series. Now question, what this code will be do? This code will create a new type of the addition class. So this is example of the constructor signature where you can customize creation of the some class by providing this class to the custom type and using here new operator. Now let's move on to the generic functions. Okay, so now we're gonna talk one of the most important topics in TypeScript. This is generic functions. And imagine that we need to write a function that will have correspondence between two types of function. Let's imagine that we want to have a function that's gonna get element of the last element of the sum array, yeah. So it's gonna be named last element. And here I need to create a structure like this, type. It's gonna get type of the variable. And as you can see, that means that we can now work with every type that will be provided to this function, to this variable, okay? And also we can return this type, yeah, variable or value with this type that will be provided to our function. So I can type here array slice -1 and call pop function, and this function will return the last element of this array. So so what this thing do? This gives to us opportunity to work with type that will be provided to this array. Yeah, for example, we will have string array or numeric array, and this function will work with all these arrays with different types. And because we type it here, that this array can get type of this variable, and it will be work perfectly. So now let's try to do one example where I'm gonna create a numeric array, and I'm gonna call here last element num array. And yeah, I can also call here type of function, yeah. And we're gonna show result in console. And also we can create here string array, and you will see that this last element function will works perfectly with all these arrays that have different elements and different types. Check string, for example, will have element like this. And now let's call here again last element function, but we will put here string array. And now let's compile all this code. And now let's go to the browser. Let's refresh it. And as you can see that this, as I said, this array will be perfectly work with every type that we provide to with every type that of array that we provide to this variable array that we created, yeah. And you can see that there is first array have number type and second array have string type. So that means that this generic functions that we created can work with every type that we want, with any types that will be provided to the array variable. So that's all that I wanted to show you in this lesson. We're gonna also back to the generic functions. We're gonna talk more about this, but for now it was just a small example how we can work with them. Summary. That was a quite simple lesson where we learned the next things. First, how to use narrowing to check types, how to use narrowing to check that function exists, and how to use a call and constructor signatures. And we learn how to create a simple generic function that will be work with any type that we provide to the R variable. Also, I want to say that in future lessons we're gonna meet generic functions again with some examples, and that will help you better understand how to work with them. That's all. So thanks for watching, and we're gonna meet in the next video. Hi and welcome to the 5th lesson of the TypeScript crash course. And here we're gonna talk about interfaces and objects, how we can create, implement and use them. So let's begin. What is an interface? So first question, what is an interface? Maybe you already know what is interfaces if you know what is object-oriented programming. But if you don't know, in short, it's like it's like a special structure with instructions that can be implemented in the classes. So for example, you can create one interface that will be named, for example, person, and you can type in this interface will be 3 functions that will be implemented to some class. So class that implements this interface must create these 3 functions that was described in interface that was implemented. So now let's go to the interface creation. Interface creation. You already know that JavaScript doesn't have this feature to write syntax that will be followed by some class, but TypeScript has this feature and we can use this now. So first let's create a new interface for classes that will be like animals. So imagine that we will have interface that will be named animal, and we're gonna create 5 classes that will be maybe maybe a frog, maybe a cat, maybe dog, maybe cube, or other animals. Yeah, so it will have function. Every animal, we know that every animal can make some sounds, some noises. We know that every animal needs to eat something, and we know that every animal sleep. Yeah. So now let's create a new class that will be named, for example, frog. So we're gonna create a new frog. So frog implements animal. So as you can see here, I'm implementing this interface that I created here, and that means that I need to create all these 3 functions that I wrote here in this class, because you can see there is error and there is class frog incorrectly implements interface animal, and type frog is missing the following properties from the type animal, sound, and sleep. That means that we need to create these 3 functions as I said. So first let's create a new function, sound. Sound function, but let's also create here variable, and it will be variable for every animal. And here we're gonna type name of the animal, so this will be froggy. And next we need to create here it function, and we're gonna type here frog eats worms, for example. Yeah, and we need to implement here a sleep function, and it's gonna return sleeping on the water, for example. Yeah. So as you can see, there is no errors, and cool, that was just a simple example of how to use an interface and to implement functions in the class. So we just created interface for the animals, and by using this interface we can create many other classes that will be like animals. Like we can create a dog that will have our functions like a sound, eat and sleep. Yeah, so all works perfectly. But we can also use interface as type. Earlier you said that you can use interfaces also as types. So now let's do this again with another example. So imagine that we have interface donation. It's going to be used as a type, as I said, and it will be valid variable with string type and amount variable, as it will have number type. And now let's imagine that we need to create donations by using this type that we just created. So for example, we're creating one new donation, and it will be user donation variable, and it will have type of donation interface. And here we need to specify valid variable value, and it's gonna be Mr. Testnet, for example, and amount of donations 100. that's situation when you know when you can use interfaces as types, and in previous lessons you already saw one example how it works. And also one thing that I want to show you, I shown you how you can create your functions in interface, and now let's create a product interface. And if you're creating new function in the interface, you already can specify what this function will do, but in new variable that will implement this interface as type. So first let's create a here new function, get name. Okay, it will return string type, and let's create a new user, or maybe no, I mean let's create a new product. Yeah, and this variable implements this interface, and as you can see, this error says that we need to create a get name function. Yeah, and we can create this, and here we can type, for example, returns product name. You can use interfaces as types as I shown you, and you can also specify functions also in these types, and use this feature. So now let's move on to the next topic, where we're going to talk about modifiers. So you already know maybe about this all visibility modifiers that you can use in your TypeScript classes. For example, this is 3 modifiers. This is public, protected, and private. And now let's do one example with all these modifiers. So let's get back to the Visual Studio Code. So I'm here, and imagine that I want to make this function private, so I can type here just private. But you can see this is not working because I can use this only in classes. So for example, I can create a class user, I can create here public variable that is named string, and maybe if somebody don't remember what this public modifier do, so public variables or functions can be accessed outside or inside the class. So if you type here public modifier, then this variable will be accessible from every place. And next modifier that we have here, this is private modifier. By using this modifier, you can create a private functions, private variables. And for example, now let's create a new private function that will be named, for example, gets name. Oh no, that does not make sense. So let's create maybe let's make this variable private, and this function let's make public, and it will be named get name, and this will return this name. So for example, let's try to create a new user. Let's first create a new user variable, and it will create a new object of the user class. And if it will try to access name variable, you can see there is error because property name is private. So when you are using private modifier, that means that you're making this function or a variable accessible only inside this class. So this variable will be accessible only inside this class. Yeah. But if you use protected, for example, if I will use protected modifier, that means that I can use this variable in other classes that will be extended by this class. So for example, if I create a new class admin, yeah, and this class will be extended by user class, I can create here new function. Maybe, yeah, I can just copy this and paste this. And if I will create a new admin, and if I will try to if I will try to use here get name function, that will be work. So before we gonna test this code, let's write here default value of the name variable, and let's compile this code. Great. And now I'm gonna open my browser, and we're gonna see how it works. So as you can see, all works perfectly because I got value of the protected variable that is named name, and that means that protected modifier works. And when you use protected modifier, this variable will be accessible in user class or classes that are extended by user class. So that's how it works. And let's also remember that we can use a static modifier to create a static method. And yes, if you don't remember what is static methods, I'm gonna remind you. So static methods are variables. This is a variables function that you can call without creating an object of the class. Now let's move on to the next topic. Tuple types. What are tuples? Tuples, it's a new type that is introduced in TypeScript, and this type can contain two or more values of different data types. So here on slide you can see one small example where we creating new tuple that is named user, and as you can see, this user variable can contain number or string value. So now let's try to create something like this. Let's get back to the Visual Studio Code. Okay, so I'm here, and now let's create a user. Yeah, and user will accept number as key and some string, or this can also accept and contain another string, but we're gonna use just number and string. So for example, I want to create a new user that will be saved here, that have ID 1, and name of this user, it will be Mike. Now let's compile this code, and now let's open browser. Okay, now let's refresh it, and as you can see, that's how tuples works. It's like an array that can contain two or more data types. So it's really simple, but now let's do another example with tuples. So for example, you can create multiple tuples, array tuples that can contain inside, for example, so it will be array of tuples. So I can type here, for example, first user, that is name Mike, there is second user Jane, and I can create here third user, maybe it will be named, I don't know, Frog, for example. Yeah. And now let's compile this code again. As you can see, there is no error in compiler, and we can open browser again, refresh, and as you can see, it's creating like a tuples array where we can save users and their values. So you can create this in situations when you want to, save some data, like a key or string, key value type. Yeah, this works really perfect. You can also get, for example, let's delete this, and let's delete also this. And for example, if I want to get first element, if I want to get here Mike, I need just to type here index 0, and it will get this first user as array element. Yeah, and maybe somebody have question, well, what if I want to add new elements to this tuple? So it will be simple. You can just type here user push, and for example, yeah, there is also instruction already how you can do this. And for example, typing here 2, that will be ID of the new user, and name of the user, it will be Jane, and we can also type here user in console log. Let's compile this, and now let's open our browser again. Let's refresh it, and as you can see, all works perfectly. So tuple, you can use tuples if you want to create something like an array that will work on k value logic. So now let's move on to the next topic, but that will be not topic, that will be end of this video. Summary. So what did we learn in this small lesson? We learned how to use interfaces in TypeScript. We learned how to use modifiers. We learned how to use classes and interfaces. And we learned how to use tuples types. In the next lesson, we're going to talk about types of manipulation. We're going to talk about how to create our own types and how we can use them in development. So thanks for watching, and we're gonna meet in the next video. Welcome back to the TypeScript crash course. In this lesson, we're gonna talk about how we can create the custom types in TypeScript and how we can use them as data types. So let's begin. And first topic, type manipulation. So what is type manipulation? Type manipulation is process when we want to create another type, another custom type with using another type that we already have. So let's do one small example with this. So let's open Visual Studio Code. So first, let's create a new type that's gonna be named received. So I type in here type received because I want to create a new type. Now I type it name of my new type. and I open body of the new type, and here I can, create variables of this new type. So first variable will be sender with string type, and second variable it will be amount with number type. Great, I save it, and now let's create a new variable with this one type. So here I need to define type of this variable, and it will be received variable, type that we just created, and now I can define values of these two variables that are inside this type. So sender it will be testnet, and amount will be maybe 1000. Yeah, great. So we just created a simple type for the receipt. Mapped types. What are mapped types? It's when we transform one type into another. Let's look at this next example. Imagine that we can access the user's variable by using their login. So first I'm gonna create a new type. It's gonna be named user login, and this type will have only one variable that is named login, and it will have string type. And we're gonna create another type that's gonna be named login, and I'm gonna call user login type, and I'm gonna get login. So login type will have string type because we transform it by this way, login user config to login type, yeah, to string, yeah. So that's one of the example. This is called indexed access types. Here you can see that the next transformation we defined set type of the login type is a string. So it's like, we like extending string type by typing here login. So that's one of the ways of transformation. This is quite simple, but now let's try index signatures. The next example will show you what is the index signatures in the mapped styles. So first let's create a new type that will have name book, and this type will have string variable, or I mean title variable, and options. In this option we will type everything that we want. So first we need to define here key, and key will only accept, and value it will be also string, yeah. So here we can, we will be able to type everything that we want, like in array, for example. For example, we can type here test, for example, key value. Okay, we will have opportunity to type something like this. So now let's create a first book, const book1, and this variable will have book type, and title of this book it will be cool book about TypeScript development, yeah. Now let's create a new options. So first option it will be genre, for example development, and the next parameter it will be language, and it will be English language, and then we can just type here book1. Okay, now let's compile this code, and now let's open browser to check how it works. Let's refresh it, and as you can see this created new objects that have options that we type it here. So you can use index signatures when you want to create some arrays with options or something like this, where you want to put many options that can exist or not exist. It's not all that can be optional and other. Summary. What did we learn in this lesson? First, we know now how to create custom types by using another type, and we learned how to use mapped types for types transformations, as we saw in previous examples. Short lesson, and thanks for watching, and we're gonna meet in the next video. Hi and welcome back to the TypeScript crash course, and in this lesson we're gonna talk about TypeScript classes and how we can create them. In the previous lesson you already saw an example with a TypeScript class example, but in this lesson we're gonna talk more about this. Classes in TypeScript. So here you can see one example of class creation. This is class that is named product, and as you can see there is two private variables, constructor that gives values for these two private variables. So now let's make one example with classes to better understand how to work with them. So you already know how to create classes in TypeScript, and now let's do one example where we're gonna create a new class that will be like a product class for creating new products. So let's begin. So let's create a new product class. first let's create a private variable name and the second variable description that will have string data type. And now let's create a constructor to give values for these two variables. So here we're gonna create a name variable and description variable in constructor. And now let's define values for name and description variables. So first type here this name equals name from constructor and this description equals description variable from the constructor. Great. So the product class have two private variables, as you can see, and they get their value in the constructor when we're gonna initialize a new object of the class. Now it's time to upgrade this class. And let's imagine that we can have different types of products that will have their own fields, but they will have the same functions. For example, imagine that we'll have a digital product and a physical product. That will be two different classes that will have the same functions, but they will have also some different parameters inside. And here we will need to use interfaces because the interface is like instructions for classes, as I said earlier. So let's go to the next topic, interface implementation. You already know if you want to implement some interface that you created in TypeScript code, you need to use implement directive. So now let's get back to the Visual Studio Code and now let's do one big example. As we know, we will have different product classes and now let's create one interface for those classes that will be named product. So name of this interface, it will be product, as I said. This interface will have names, so every physical or digital product have their names. Every physical or digital product has their own descriptions. And you know that for example, let's imagine that physical and digital products have buy function, but they will have own implementation of this function in their classes. So we can also create a get all info function. Okay, great. The next thing we need to do is create classes for digital and physical products. So first let's create a digital product. So I type here class digital product. And now we need to implement this product interface. And now, as you can see, now we need to define here all these variables and functions that we have in interface. So first let's create a variable. So first this is name variable, second variable this is description. Next what we need to do is create a constructor function. We're gonna use this constructor to create to give values for these two variables that we have here. Description equals will have string type, and now we type that this name equals name and this description equals description. Great. Now let's create a by function. So there will be our way how digital product will be will make by operation. For example, we're gonna just return here I'm buying a digital product. So just imagine that here we're gonna, if it will be a real project, we're gonna write here special functions, special codes that will be work only for digital products to make purchase operation of digital product. And now let's create a getAllInfo class that will return information about digital product. So we're gonna just type here digital product info. And we're gonna type, first we're gonna show name of the digital product, second we're gonna type description of the digital product. Great. And next thing what we need to do is create a physical product. So I type here physical product, and this class will implement product interface. Great. And yeah, let's also add here enters. Great. Now we're gonna do the same things that we did in digital product, but as I said, digital and physical products have their own implementations of these two functions. So they do different operations for getting information or by function. So here I'm gonna type I am buying a physical product. So just imagine, as I said, that here we're gonna now, if it will be a real project, we're gonna write here code for purchasing not digital product, but a special code for purchasing physical product. And yes, here we can, for example, type physical product info. And you know, it's look like some kind of fabric method, fabric pattern, desync pattern. Maybe somebody knows what is it, but I'm not gonna tell you how to use this pattern, because for now we have lesson about not patterns, about TypeScript classes. So if you want to learn more about desync pattern, just find some information and you gonna know about this great tool in development. And you know, desync patterns will help you to build your application fast and make better quality and flexible for coding. Okay, so digital and physical products classes looks similar, but you can see that there is an own implementation of methods that are provided by the product interface. So that was a nice example of how you can implement the interface to your class in TypeScript. And now let's move on to the next topic, constructors in classes. Constructors. We already know that we can use a constructor method if you want to do something when we just creating a new object of the class or giving values for the class variables. First, let's look at the next example where we're gonna see a class with multiple constructors. So first let's create a class that will be named multiple, and we're gonna create here first constructor that will have only two variables, x and y. X and y, and you can see there is constructor implementation missing. Yeah, no, okay, I fix it. Now we can create here another constructor that will accept only x value here, yeah, x variable I mean. And next thing what we need to do, because it will be class with multiple constructors, we need to create one constructor that will accept all arguments. So first we're typing here 3 dots and creating array that will save all arguments. And yeah, I will use here any function to accept any data types in this arguments array. So we're gonna use this arguments array for, you know, for creating like you know, for working with all arguments that we're gonna get here. Okay, so yeah, also for delete bodies of the classes, now it's gonna work nice. And now let's create if we, for example, have one argument, yeah, we're gonna console log there is one argument in constructor. So as you can see, you need to use, you know, you can use multiple constructors if you want to create a flexible class that can accept you know, some optional variables, and that will be not have errors. Yeah, and also if, for example, we will have two arguments, we're gonna write message there is two arguments in the constructor. We can type here constructor. Now let's create a new object of the multiple class. So let's type multi variable that's gonna be named multi object. I'm gonna type here multiple, and you can see I provided here only one argument, and there is no errors. That's because as I said, I created two multiple constructors. This says that this class can accept one or two arguments. And for example, I can create a second here object, yeah, of this class, and you can see I can this class also can accept two arguments. Now let's compile this code. Okay, now let's open browser and check how it works. Okay, let's get back to the browser. Let's refresh it, and as you can see, all works perfectly. There is one argument in constructor, this is in the first case, and there is two arguments in constructor, this is in the second case where I typed two arguments in new object. And as you can see, this is how our TypeScript compilation works. It's look, you know, in some kind strange because there is functions, but this is like a class. So you know, let's get back to the TypeScript code because we have interest only to the TypeScript code. So this is a popular example to show you how you can create multiple constructors for your class. It's important to create a public constructor function that will receive all arguments that are provided in the class constructor when we are creating a new object of the class. You can use multiple constructors when you want to create a flexible class where it's not required to provide all variables in the class constructor. And okay, now let's move on to the next topic of this lesson: static methods in classes. So you can see on the slide quite simple example where we're creating a static variable that is named name, and you need to add this it's like a sharp symbol before creating static variable. And if you want to create a static function, you need to add after visibility modifier static directive. So now let's move on to the Visual Studio Code, and now let's make one example. In this section we're gonna talk about how to use static methods in TypeScript classes. Maybe you already know that static methods and variables, these are methods or variables that you can call without creating a new object of the class. So now let's make example. So I create a new class that is named static example, and there will be static variable that will have default okay, maybe I don't know, maybe you can type. Yeah, okay, all works. So I'm gonna type here static variable, and yeah, so we created new static variable that is named name. And now let's create a new static method that we're gonna use to get this variable. So we're gonna type static function get name, and it's gonna return this. Okay, why I see here errors that private identifiers. So I fixed it and I forget that we don't need this sharp, because sharp it's like a private method. You need to just have private methods in vanilla JavaScript to can declare with using sharp. But you can see that I created here super name. Why not name? Because if you want to type to name, you can see that this is property is already built in function class, so we need to use some other name. So I'm gonna use super name. And now let's do next thing. Let's compile first this code, and let's type here static example, and let's try to use get name function, and let's compile this code again. And now let's open browser and refresh page to see how it works. And as you can see, all works perfect. So we get value of the static variables that we just created. And now we're gonna talk about next topic that will be about abstract classes. So let's get back first to the Visual Studio Code. Great. So this is the last section of this lesson. We're gonna talk now about abstract classes that we can use as a base for other classes. Let's look at the next example. So first I'm gonna create a new abstract class that's gonna be named phone, and I'm gonna create a here abstract method that's gonna be named call. So you know that every model of phone can make calls to other phones. So that's the reason why I'm creating here this abstract method. And now let's create a smartphone that will have our implementation. Smartphone, yeah, extends phone. So if you want to use abstract class, you need to use extends, not implements, and you need to use extends directive to use abstract classes. And we're gonna create our own implementation of the call function. So we're gonna type here I'm calling from the smartphone. So that means here's one error. Okay, so smartphone can make their own operation of how they make calls. Yeah. So now let's create the second model of the phone, that it's gonna be cell phone, and we're gonna also create our own implementation of the call of the abstract method call, and we're gonna type here I'm calling from the cell phone. Okay, and now let's try, for example, to create a new cell phone. Okay, I forget we don't using PHP, so I can call now call method from the cell phone, and let's also call method from the smartphone. Okay, now let's open browser to check how it works. Let's refresh this page. Oh, I forget to compile my code. Let's get back to the Visual Studio Code. Okay, now let's type here TSC. Let's compile all this code. As you can see, there is no errors. Now let's get back to the browser. Okay, now let's refresh it, and as you can see, all working, because you can see that first we calling call method from the smartphone, and smartphone make an operation of call, and cell phone make an operation of the call operation. Okay, so in our world we have many different types of phones, and this example shows that we are creating smartphone and cell phones classes with our own implementation of an abstract method that is used to make calls. So also I want to say that abstract classes can also be used as interfaces, and you just have a small example of this because we use it abstract method call in abstract class phone as an implementation of method. Yeah, so now let's go to the summary of this lesson. Summary. The question that I ask at the end of every lesson is, so what did we learn? We learned how to make interface implementation for classes. We learned how to create multiple constructors. We learned how to use static methods. We learned how to create abstract classes and how we can use them. So that's all for this lesson. Thanks for watching, and we're gonna meet in the next video, if I will record next video. So thanks.